We are live.
On the YouTube page. Yeah.
We are live.
On the YouTube page. Yeah.
So we have one new participant, Akhilesh. Hi, Akhilesh.
One.
Hi, Akhilesh. So when you're not speaking, could you? We have one new participant, Akhilesh. Hi, Akhilesh.
One.
Hi, Akhilesh. So when you're not speaking, could you? We have
Hello. Hello.
Yes, Kapil.
Okay. So the sound is gone, right? There was some echoing sound. Everything is clear. We are broadcasting. Okay. So let's first. I'll give a quick introduction about Cloud Month. Cloud Month and FreeCodeCamp Hyderabad. So FreeCodeCamp Hyderabad is a general developer hub. We are not specific to any technology. We just are a general developer of people, experienced or beginners, to come together to share resources, learn together, and we organize frequent meetups on different kinds of topics. And recently we decided uh, we have a new. So Akhilesh, can you mute your microphone? Yeah, just make sure that everyone mute your microphone unless you're talking. Okay, can you guys hear me? Okay, good. So okay, Raja Shekhar has joined. Raja, can you turn off your microphone? Okay, good. So FreeCodeCamp Hyderabad basically is a community of developers, and if I have to summarize the entire community and what we are all about in one single statement, it would be that we are on a mission to improve the state of software education and software development in Hyderabad. We started off as just a local Hyderabad chapter for freecodecamp.com, but in recent times we have evolved beyond that. So that's FreeCodeCamp Hyderabad, and hello, can you guys hear me?
Yes. Yes.
Hello, can you guys hear me? You can hear me? Okay. So as I was saying, that FreeCodeCamp Hyderabad. Okay, so recently we decided to do a series of meetups on cloud computing and decided to call it Cloud Month. The idea was that we are in touch with all the major standard cloud platforms from AWS to DigitalOcean to Google Cloud Platform. So why don't we do like a series of meetups to get people started with all these platforms? So we have already the rest of the meetups we did physically. We started off with Azure. We did the Azure meetup at Microsoft campus in Gachibowli at the start of last month. And then we did a meetup with IBM Bluemix at 91 Springboard. Then we did a meetup with DigitalOcean and AWS at Vision Labs last weekend. And this weekend we were planning the GCP meetup. Venue-wise, we were trying for Google Office, and we were most likely going to confirm it, but we couldn't. They had some other event planned, so we decided why not do it online. So this is an experimentation. We are not completely certain how this will go. And we do plan to do lots of other events and meetups sessions online as well as offline. So this one is the GCP webcast, and that's pretty much about Cloud Month. From here, I think Gautam, you can take forward.
We can't hear you, Gautam, if you're speaking.
Yeah, we can't hear you. Hello, Gautam. So I think Gautam has tried to, he has left. He'll be trying to join again, I guess.
Hello, can you hear me? Hello?
Yeah, we can hear.
Oh,
Yeah, we can.
really sorry. I don't know what happened back then. I just spoke a lot without realizing that I was not audible. So sorry. So I was saying, guys, there'll be 2 sessions, both hands-on, and you can follow along as the speakers take you through the steps. But for that, you'll need your own Google Cloud Platform account. I'll put the link for the signing up. It's a free account. You get $300. I'll put the link in the chat. If you don't already have an account, please create one. It will be easier for you to follow along. And the first session will be on Google Cloud, Google Container and Compute Engines by Ronak. So, Ronak, are you there? Hello, Ronak.
One of your microphone is turned off, I believe.
Hello, can you guys hear me?
Yeah, we can hear you, Gautam. We can't hear Ronak.
Oh, okay. Yeah, Ronak, we can hear you now. Ronak, 1 minute, just a small thing. Your voice seems too low. Is it just me?
Yeah, it's low. Even I can't hear.
Oh, yeah. Okay.
Yes, it is low.
Sorry, Ronak, we can't still hear you.
Okay, guys, I think Gautam is having some issues with the microphone. He's going to rejoin the call. Meanwhile, please hold on. Hello? Am I audible? Yeah?
Yeah, Ronak, you're audible. You're audible.
Okay, so shall I proceed? Yes, Ronak, please proceed. We're able to hear you.
Okay, so I'm gonna
You
share.
have to turn off your microphone.
Okay, cool. I'm gonna share my screen now.
You want to start with a quick introduction of yourself, and then you can start the session.
Yeah, yeah, that is the plan. I'll introduce myself and then go along that. Okay. So basically, I am an open source developer. I've been working in the field of containers for last 3 years. I started working on Docker, and then after that, I've been exploring the Kubernetes and Docker Swarm based architectures. I've worked with a startup where we did a lot of work with LXD. Those are the system containers, whereas Docker and Rocket are application containers. So basically, you can say that I love containers, and Google Compute Engine has a very good Kubernetes service. So basically, I've tried that, and that is why I know Google Compute Engine. So yeah, I'm hoping that I can explain Google Compute Engine well. But since it is like first webcast and we do not know a lot of things, so I've tried to keep my examples very simple, which are replicable and easily available online. And also, I've created a Git repo uh, for all the resources that I'm using. So even this slide is publicly available. So basically, if you are having some doubts, you can always ask on our Twitter channel. Um, uh, and yeah, that's it. Someone will reply to you. Meanwhile, we'll try to put on some demos and all. Okay. So here goes. So this is just I already introduced myself. Currently working on Kubernetes. So basically, I've worked on these technology stacks: Docker, Open Tracing, Kubernetes, and LXD. And most of the time, I do not use cloud, but if I have to deploy uh, in large quantities, cloud is only option, a sensible option to this. So basically, um, locally I can build on my laptop, but I need cloud for further applications. Okay, so before we begin, I have already posted the link on our Jitter channel, but for those who are not on Gitter channel, they can go there or just go to this GitHub repo where I have mentioned all the sources for today's session. So now, like we start with the general introduction of a Google Cloud platform. So basically, these are the bunch of services that Google Cloud Platform provides. These services are very similar to other cloud platforms. It just there is difference in namings. So, but Google has something different called App Engine. So basically, in App Engine, you only write code. You do not ever worry about managing instances, managing machines. How code?
Ronak, there's a small issue.
Yeah.
Like, sorry to disturb. So in the live telecast, your screen is not visible.
Oh.
So we'll check if there is a.
Okay, I'm sharing.
Yep. Give me 1 second.
What?
Just escape.
Ronak, can you actually stop sharing? Okay, yeah. Now it is visible. Let me check on the.
I think this is the lag happening.
No, it's not a lag actually. So still your face is visible, like your picture is visible, but not the slides.
Oh, okay.
Yep, now it's visible. Thank you. Yep. Now we can continue. It's visible. Thanks.
Okay. So Yeah, so right now we have like
Share the entire application, right? Still it's not working. Yeah, I think this is working now.
okay, so basically we start from the beginning. So I was just describing Google Cloud Platform. In Google Cloud Platform, we have bunch of services, and this is the App Engine. So basically, in App Engine, you just write the whole code, like in a Node.js code. Your application could be a Node.js application, and you do not have to worry about maintaining machines, doing using Shaft, Puppet, configuration tools like that. Okay. So yeah, and then next is the compute engine that we will cover in the detail later. And my friend will be covering BigQuery. So these are the bunch of different applications that Google Cloud provides. And today's topic is Google Compute Engine and Google Container Engine. So these two services are not covered in the previous diagram because these are just emerging services. So Google Container Engine is nothing but Kubernetes deployed on Google Container, Google Compute Platform, and to the extension of Google Container Engine, there is a service called Google Cloud Functions, which is mostly the replacement or analog to AWS Lambda functions. Okay, so basically you can write serverless applications. So just write functions of Python or Node.js, and your infrastructure will Google Container Engine will take care of those. So these are the different abstractions in which we are working. We will be covering the Google Container Engine also later. So here goes nothing. Google Compute. So basically, it is an infrastructure as a service. You can assign storage. You can have unlimited amount of compute power, and you can have reconfigurable network. You can design your VPCs, set firewall rules, everything. So everything to do with the workload. You can just define what kind of workload you want. You want GPUs. All of them are available in Google Compute instances. You want SSDs. All of those are there. These are just sub-hour billing. These are just kind of features that you use for business purposes, but that is not for today, this session. But you can do a lot of things.
Let me see if you can get full screen.
Okay. Okay.
Carry on.
So before we dive into any demo, we are just gonna do this simple workflow analysis. Like how does you create anything in Google Compute Engine? So Google Compute Engine has an object called project. So okay, so each application will be abstracted under the object called project, and these project can be deployed in region. So region can be Asia, Australia, North America. Okay, and in that there are that region is divided into subzones. So depending on your application and depending on where you want to deploy it, depending on different conditions, you can decide all of these things. And in that zone, you initiate bunch of instances. Okay, and you can always attach storage, attach more hard disk local space to that instance, or attach it with a Google Cloud SQL or Google BigQuery. Then we have something. So each project has a network. So basically, you can in network you can define what kind of IP addressing schemes can go in particular zone or particular region. You can encapsulate those details in simple JSON configurations, which we will see later. Uh, and similarly, you can configure your firewall, which ports will be open for your application, like 443 port or 80 port. So all those kind of things are available with GC Google Compute interface. And then there is load balancer, which is like if you want to scale up your application, how would you do it? So basically, load balancer is also come as a service in sub-service in Google Compute domain. Okay. So this is just about network. Like how do we do TCP? We have TCP, UDP, ICMP protocols available. Networks are private to a project, which I explained earlier. So basically, public IP addresses, you can issue public IP addresses for a long time. You can own them depending on your use case. Like what is your use case? If you are working in more of a serverless applications where it doesn't matter where your code is running, you will not try to hard code your IP addresses in the in your application. So ephemeral public IP addresses would do. Then within your VPC, there will be bunch of VMs or containers who will be associated with some private IP addresses in some subnet. So all of those things can be done, and just like AWS or Azure, you can design you can decide what kind of firewall rules can be there, IP forwarding, and all those things. So coming on to the next, so these are just concepts that exist in Google Compute Engine, and some of you might be familiar with these concepts because these are just like very basic design principles on which these are based. So one is so Google has something called Cloud Console, which is very good because they have executed it very well. You can just write a simple app, simple Nginx server and Nginx server and MySQL server as a backend in your browser only, because they provide you a browser-based SSH to your Google infrastructure. Then there is Cloud SDK. So these interfaces are just a way to configure your Google Compute Engine workload or your application. So depending on what kind of application, what kind of service you are using, its use will change. And then there are REST APIs. So Google has been abstracted away all of its API. So basically, you can use configuration tools like Chef, Puppet, or Ansible, or even Terraform. Terraform is another kind of configuration management tool. So basically, you can just write these playbooks, Ansible playbooks, or Chef recipes, and among others. Like they all have different convention, but the idea is same, that you have some kind of configuration files. So these configuration files are posted to the Google Cloud Platform with your credentials, and instances and data gets allocated, disk get allocated. So basically, you can do all kind of stuff with Google services that we saw earlier. So now, okay. So now we go for a simple demo. For demo, you can go to this site. So basically, I am following. So Google has provided their own. Yeah, Google has provided their own tutorials, very interactive tutorials, which are very easy to follow. So basically, here is the link, and these are the different other ways that I have found very interesting, like native way, via Ansible or via Terraform. So you can try all of these approaches. These are very good blogs that I've tried. But in today's session, we are gonna native way, and for the sake of convenience, we go for interactive tutorial. Okay, so basically, as you can see that there are different kind of things. We are gonna try compute engine first, but as you can see, if I click here, I can try app engine. I can try compute engine also, which is here, and then try container engine also here. So basically, these are different kind of tutorials that are available. So let's get started with our first demo. Okay. Yeah. Voices. Okay, so just like in our workflow, we found out that this is the workflow that is needed. So basically, we are gonna create our first project. So project is the basics abstraction. I can name it like. Okay, so we have created our project. Okay, so basically we have allocated some namespace, which is FCC Code Lab, and like everything, they have some absolute ID, uh, uh, absolute ID, and now we have like so this is like a dashboard, just like AWS dashboard, and for this project we have different billing that can come. So basically, if you deploy an application in project, the billing for that application can come as separate. So basically, this is interesting because you have separation of concerns if you are running multiple applications from the same account. So now we'll still go with the this one. So now we want to try compute engine. Okay, so basically we wanna create some VM. Will it take some time to get it ready? Meanwhile, you can ask any questions, any doubts on the GitHub channel, so that we can answer it to you conveniently. Okay, you can post it on Gitter channel also, or you can post it on our YouTube uh, live link. Okay, so basically you can see that. Okay, before criticizing, it corrected itself. Oh, how's billing calculated? That is the question by Akhilesh Kota. So basically, for each VM, as we will see when we create a VM, we get some pricing. So there is pricing for different service. So as you can see here, when I'm trying to create an instance, it gives me some estimate of $31.69 per month. So a billing is the sum of like total services that you are using per hour. Okay, so they charge you on the hourly basis, effective hourly rate of $0.043 for 3.75 GB of memory. That seems good. I do not want to change anything. Just I like Ubuntu, so I'm gonna go with Ubuntu. And these are the different firewall things I can change here. I can add some ICMP ports, SSH ports later on. So, but interesting thing is it is very user friendly. It says that how you can create a REST thing from the REST API. So basically, you can do via Linux curl command. You can invoke this instance. Okay, or you can do this command line thing. So basically, this is the G Cloud. This is the Google Cloud SDK that we talked about. So basically, you can run in Cloud Shell or stuff like that. Okay, but this time we are gonna go with this. Yeah, I want to create one instance. This is an Asian Northeast. So I didn't prefer any zone. So it was just default. You can try it with the different configurations that you want.
Ronak, did you mute your microphone on purpose?
Oh, hello.
Yes, the audio is back. Sorry about that, guy.
Okay. So yeah, basically, instance is just a computer machine that you pay for on hourly basis, and you can define the characteristics where it is located and how much, how big, how powerful it has to be, whether it requires GPU or certain special things. You can define that whether it has to be a magnetic hard disk or SD, solid state drives. So basically, all of those things you can define. So basically, instance uh, is your computer VM in very technical terms. So basically, these are very large machines where you Oh, okay. So instance groups and templates. So yeah, I'll go into the that just now. So basically, let's click onto the instance. So basically, we get all kind of information like what is the graph, how is the CPU usage going on, and these are different metrics that I am concerned about, like disk operations. If I have very uh, highly IO sensitive application running, like database crunching application or something like that, or data mining, data crawlers, web crawlers applications, there will be a lot of disk operations. So basically, I need to monitor all those. Uh, I get read and write rate. So basically, this is just a bunch of things that I have. I also get this public external IP address, which is public IP address, which is allocated to me, and it says that this is ephemeral. So basically, maybe I could do something while initiating the instance. I could assign some public IP address that I might have allocated to me only in my account. So basically, in that case, I can choose from the public IP that I have. Okay, sorry. Yeah. So now the question is that what were the instance groups and instance templates? So I guess instance, first I go with instance templates. So basically you have some bunch of software, like you have defined your own open source version of Kubernetes, okay, or any piece of software which you have modified, and your VM VM to initiate with that software configuration inbuilt. So one way to do is that we can create after booting this instance, I can just install that particular configuration in this instance and make a template out of it, okay, which I can call like my Kubernetes. And so from the next time when I do instances, when I want to create a new instance, I can just say that do uh, uh, use the template my Kubernetes, which is based on Ubuntu 16.04 and has this particular piece of configurations that I've already done and which I do not want to do again and again. So basically VM starts from there. So that is the power of VM. You can snapshot your state, and your new VM starts from that state only. So now okay, so basically these are different kind of services that can be enabled from here. Now let's go into this SSH. So the way this thing works is that you need to have each VM is allocated a key. So basically, I want to check. Yeah, it works. It shows me that it has it shows me that it has 3.75 GB of RAM, and nobody is using so this is just the statistics. I can do a lot of stuff. So I also get this credit thing. You have $294 in credit and 359 is left for free trial. So basically now so now I can do bunch of operations. So basically I want to do simple update. So it gets updated. Okay. So this is the VM I have. Now I can install my Nginx server. So let's say I want to do basically now we are gonna deploy an application which is exposed web application. Meanwhile, till it is happening, we go on to our next thing, which is security groups. So basically, I forgot to mention there are bunch of commands here. You can stop your VM. You can clone VM with the exact replica. And so one I'm looking for. So now I want to create a snapshot of my VM. Sorry. Excellent. So basically, now this is created as a snapshot. So basically, there is a difference between snapshot and templates. So a snapshot is something that we do to take for application recovery, like an application which is running healthy at a certain point of time might not run in good mode like just a minute after. Okay, so basically we take a bunch of snapshots at regular intervals so that in case of some error we can go to that snapshot. Obviously there are multiple ways to ensure that such kind of problems doesn't occur. The another way to do is that you you configure your load balancer, and that load balancer initiates the same initiates a different VM with the same configuration. So basically, the load is transferred from error VM to new VM. So basically, these are two different approaches. One relies on redundancy, and the other relies on strong state preservation. So snapshot technique is a state preservation. So basically, I say snapshot. So basically, snapshot happens at when my application is currently running, but instance templates now. So now this instance template describe VM instance. So basically, but it cost us a little, $24.67 per month. So, and you can this is the breakup of our fee structure. So basically, these are the bunch of things that you can do depending on your needs. Let's check this. So these are the SSH keys that were generated. So basically, if you want to log in directly to the machine from your terminal, you need to save this as a SSH key, this SSH key in your .ssh folder, and use the public IP and do SSH thing from there. But one thing that you have to do here is that you need to configure your firewall so that it allows 22 port from outside. Then we have health check. So health check is a bunch of monitoring tools over your VM. So basically, if you want to check so basically, the question is that difference between snapshots and templates. So a snapshot is, as I said, that it is the current you preserve the state of your current running application at certain point of times in regular intervals. It means that your application is running, but you can always revert back to those snapshots. But the use of templates are also like snapshots, but you create templates. Yeah, snapshot is like a restore point. It has all the files and all the cloud things, all the applications that were running at that point of time. You can restore it. You can restore it back. So, but the templates are an object which lets you create the VM with predefined configuration. So basically, when in this case we decided to use Nginx and MySQL server, we decided to install in our current instance. But suppose if I do not want to do it every time, even with chef and all, I can just create these instance templates which has already like some applications pre-installed. So basically, I can just start with that. So that allows me the quick creation of VM, because even if you configure an application, it takes certain seconds of time. So in order to save those certain seconds, there is a trade-off between time and memory. So basically, instance templates is a memory thing going on. Okay. So basically, your memory is cheap. Instance templates can be put as a memory thing. Okay. So if you want to save your time, you put more instance templates so that your VM is created as soon as possible. without even configuring. Yeah, so templates are pre-configured settings. Yeah, something like that. So now these are, we can see Jones also here. To create instance using template. So basically first you have to create instance. So let's create this one then. Okay. So basically, it's just like creating a different instance. But the thing is that now whatever changes that I make will be stored as a configuration file with the Google Compute Engine. So so the next time I create, so this is my just simple template. Okay, so now I want to create a VM instance. So basically I can take it from snapshots. These are the different instances, templates that we have available. Okay, like application images. So basically SQL Server is built in there. And then we have from these different projects, I can import my images. Yeah, and GPUs are not available. Okay, now I have GPUs also. Basically, I can assign some GPUs also, but it will cost me a fortune. So $4 to $4, not good enough for free trial, but yeah, if you want to, you can try. Okay, let's see. Do we have some questions? Nothing as of yet. Yeah. So basically, I created a template. Just I want to launch 3 instances. Okay, now I'm gonna create it. So now this instance group consists of 3 VMs, all with the all will have a pre-configured instance template FCC that we saw here. So basically, we created a bunch of instances, a bunch of VM instances from FCC template. So that is the basic of templates in the compute engine. You can always check out these applications, the bunch of applications that we have here: App Engine, Compute Engine, Container Engine. We'll go Container Engine in a few minutes, but you can check out these services and ask me questions, because that would be good, because there is less interactivity here. Ask any kind of service which you are having problem with. So these are the storage services which will be covered by me, and these are the stack driver. So basically this is for if you have a microservices architecture, these kind of services help you, because you need to have logging, and how do you do trace thing. So this is a very awesome tool. So if you are building a stack, a microservices based framework, this trace works this trace is awesome too. And we also have an open source equivalent to it, which is called Open Tracing. So basically you can check it out. So this is for writing maintainable, error prone production systems. Then we have something called endpoints. So basically endpoints are the extension of Google Cloud. So basically these endpoints can be connected with different third-party APIs so that basically you can just extend your Google Compute Engine to different services that are out there. Suppose if you want to do IRCTC thing, okay, every day you want to see a certain number of trains. So basically going with IRCTC API, and based on what kind of analytics that you want to do, you can build a knowledge on the top of IRCTC. And this deployment manager is the configuration tool, configuration tool managed by Google Compute Engine. So it's like a chef kind of thingy, which lets you manage lots of deployments if you have like hundreds to millions. So basically it's just a paid service. Similarly, source repositories like Jet, hosted Jet, container registry we will see. Then these are different ML engine. Well, I do not have much exposure to these services, but these services are for different data processing, analytics workloads. So basically you can check it out, and in case you have problem with the compute storage or these tools, I can help you. So basically we have done instance group. Now we want to see what kind of VMs we are running. So basically we are running 4 VM, and 3 of VMs were created by each has their IP, an external IP, and all of these 3 are created by that instance template FCC. Okay, so just because we are not doing anything, I'm gonna delete these 3. But first, stop. Okay, so any questions till now? Okay, so yeah. Okay, now on to the next thing. We go to container engine. So basically, Google Container Engine. So basically, let me just give you brief idea that what containers are. So just like VM, which encapsulates a complete operating system, we have something called containers, which is used for encapsulating just processes, not complete operating system. So the idea is that one application in one container should not see the another application in another container, which is similar to VM, where activities in one OS, which lies in one VM, cannot see what is happening in OS of another VM. But the abstraction that we talk about is not OS level; it is process level. And in order to achieve that, we have something called C groups and namespaces, which were introduced in Linux kernel greater than 3, I guess. Well, they were introduced in 2.6, but like major work keep happening in the version 3. Okay, so basically C group is the resource allocation hierarchical set of rules, just like ASCII Linux, where you can define bunch of rules, chaining rules to restrict network inflow or outflow. C groups are kind of hierarchical rules that you can impose on resources like compute power, UID, storage, hard disk, input-output rate. These are different kind of C group classes, major classes we have, resource classes. So basically you can define how much a particular container should use how much of that particular resource. Okay, and the namespaces are something which gives you the perception that you are running a completely new container. So namespaces are like it gives you while you are running inside a container, you will see your process PID as something called 235, but in actual operating system it might be some 2000 PID. So basically namespaces are like PID, NAT, UID. These isolate the view of applications that are running inside containers. So if you are running a malicious application inside container, it cannot see what other applications are running in the same operating system, and also it cannot see what applications are running in different containers on the same operating system. So basically these are the two very important concepts that constitutes the idea of container. Then like 3 years back, we had these LXC Linux containers, Docker and Rocket were formed. So basically these were the application containers which you can use, and they also came up with this idea of configuration files. So basically you can define your whole application as a configuration, and it will kind of run, you can define your whole application as a configuration. So basically if you want to do Ansible thing, so basically I'll show you one of the Docker. Okay, so basically you can define your whole application just like in VM, just like in template thing that we did previously. You can define a template for your container in terms of Docker file, or for Rocket we have app specification. For LXC we have simple bash script. Okay, so basically in that when you invoke these containers, they come with the predefined configuration. So basically a lot of configuration thing, chef work is offloaded to these configuration files. So that helps you a lot in building reproducible environments. So once we had the idea of containers were refined, we wanted to run in the swarm of containers. Like I wanted to run a cluster of containers. So basically, we had two major projects that took uh, uh, that took the lead. One was the Docker Swarm, which is very easy to use, and the second is Kubernetes, which is based on Google's Borg paper, BORG paper. So basically, they have different. So basically, when you are running millions of containers simultaneously, uh, this is strictly a microservices based architecture. So there need to be a lot of communication, a lot of networking, mumbo jumbo, because you need to connect uh, all of these containers. All of these containers should be able to talk to each other. So basically, we had to define a lot of networking capabilities. So in cluster. So basically, Swarm deletes lots of hides lot of these implementation details, but Kubernetes on the other hand exposes it. It is very configurable, and you know people can really try out very complex network stuff on Kubernetes. So basically, that's why, and it is backed by Google. So basically, that is the another reason why people are doing Kubernetes. So basically, you can deploy the containers, cluster of containers, which can run over the multiple zones, multiple regions. So basically, even you have an error-based container, you can just download. Download and um, uh, another container of same template and remove the error container. So basically, in that way, it is very awesome because you can invoke a container in matter of seconds, whereas it takes 2 to 3 minutes to invoke a VM, and also it is less resource consuming thing. So that's why container building containers in your infrastructure or using containers in your infrastructure will let you reduce the cost of cloud. So the in the end all of these companies like Google Cloud, Amazon, uh, they are supporting the enterprise version of Kubernetes for you. So Google Container Engine is the Kubernetes maintained by Google, uh, although it is open source also. But this is the enterprise version of Kubernetes. Okay. Uh, So any questions regarding Docker or all of these things will be entertained. I can explain it to you. Meanwhile, we'll start with our basic stuff. We want to create. We want to create our containers. So basically, I'll just show you how to do it. Just in case if I'm not able to clear the doubts today, you can always email me or ping me on Jitter, uh, or yeah, email would be best. But let's see what we can do today. So we have we want to try container. Okay. So basically, the idea is that you deploy an app. So basically, first you decide that what should be the container configuration, like what would be the cluster size and all those things. Then where similar thing, which zone you want to be in, which region you want to be in, which region you want to serve very fast, and then basically once you have decided that this is my configuration of cluster, then you deploy uh, an app, and after that you test your app. So let's go. Okay, so basically creating too many projects also can give me pain. So basically I'm gonna do this. I'm gonna start in FCC thing only. Okay. So this is giving me all of these details. Okay. Okay, so the idea here is that you can have one vCPU or very small instances. So just because previously we were running VMs, we would need a very large amount of memory. But in case of containers, my containers could occupy as small as this 1.7 GB or very micro containers. So I'm gonna go with micro containers. Okay, I want to invoke a cluster of 4. Let's say 6. Then okay, so idea is the automatic upgrades. So basically the automatic upgrades is that suppose if you so each container is running a template. Okay, a template like of thing like Docker file that we see here. So basically so basically this is the Docker file thing. Okay, this is a little bit complicated. I'll give you better example later. So uh, okay, okay. So basically once you so okay, sorry. So basically if you want to change your Docker file it's Docker file DOCKERFILE. So basically if you want to change your configuration of container if it will automatically update the new software I'm here. It will automatically update the new configuration of your application. Suppose if you were using Nginx version an Nginx older stable version, now you want to change to Nginx beta version, but you want to do it in production server. So basically what you do is you update your Docker file, and our container cluster will detect that you have updated your Docker file. So it will gradually down existing containers and replace it with the new containers. So basically you have new piece of software running in a cluster without any downtime. So that is one good advantage of using container clusters. Okay. Okay, I have not tested this automatic repair stuff. So basically these are the bunch of things. So now you can see that in VM we never had need to do this stack driver logging, but in this case they have done stack driver logging because our containers are independent units. They can be running on multiple VMs. So but still we want a centralized view of whatever is happening with our applications or whatever is happening with our cluster. So basically they have we have to do something about logging, whether you can use their logging, or we can deploy our own logging softwares. Okay. Auto scaling on. Okay. So basically, I can also do auto scaling. So basically, I say that my minimal size of cluster is 6, and maximal size would be go to 10. Okay. So basically, this says to me that that in case of load, in case my application, my 6 containers are not enough, uh, uh, Kubernetes or cluster will scale it up to the 10 containers, or I can do 100 also. Okay, that depends on load, but you should be very careful in doing this kind of setting, because suppose auto scaling happens, you do not know the algorithm. So suppose if it scales it on very regular basis, then you will have a lot of this bill, Google Compute Engine bill. So you should always be careful, but I guess this works. And you can also downsize also. So suppose I'm running a cluster of 6, which I mentioned here. Okay, but if there is no load, I can downgrade it to at max minimal 3. Okay, and then these are the bunch of things. Okay, I'm gonna create it. Okay. Okay, so my container is getting initialized. The important point is to remember that in general case, I am running in cloud. I am running either in bare metal or VMs. So basically, my cluster are the container cluster. For container cluster to get created, first I had to allocate enough amount of VMs which can accommodate the needs of the cluster. Or if I'm doing the bare metal thing, then I need to allocate the whole complete 32 core 128 GB of memory there, 128 GB of instance there. So basically, in any case, I am deploying it on VM, but the amount of VMs and the flexibility that has been provided with just invocation of container is tremendous. So basically, even though we are deploying on VMs, it doesn't matter, because our response rate with a cluster based, a container based cluster is very high. So I can have a VM in one zone, one region, and VMs in another region with the same zone. I can effectively load balance in faster way than having the whole VM based load balancer approach, VM cluster approach. So now it is getting created. Let's see. Any questions till now? Okay. See, we have compute cluster created, and these are the 6 instances that were created. Okay. Now I want to do this. want to see. How to get tutorial view. I posted the link here. Uh, so basically, go for this interactive tutorial. Can we connect instance with on-premise network? Uh, can you explain a little bit on on-premise network? Basically, is this network under your control? Uh, because I'm not very familiar with this term. Uh, big,
I think one of the meaning I can interpret is can if you already have something running in your on the network, can Kubernetes access this? So it's a network issue, I think. So you have to open up some kind of proxy in your own local data center so that it can be accessed publicly.
yes, you can set firewall rules, right?
Yeah, I think that was the question.
Yeah, you can enable the ports. Okay. Okay, I guess this is. Um,
Hi Ronak, just a small reminder that we are running out of time.
yeah, I guess this thing is done. Means,
Yeah.
so we have cluster containers here right now. Now we want to configure some applications on it. Just in case those who have not still got it, uh, there is a link in Google Compute Engine, this repo, and from there you can just go uh, here. So this is the console.cloud.google.com/start, and you can try different things, uh, different applications here. Okay. You can run and learn about different services. So basically, now I want to do this thing: how to create a Google Container Engine and deploy some applications. Let's do this. Now we are going to go for FCC project. Okay. Okay, I have already created the cluster. So undo the command. We open the terminal. Okay, then our next thing, kubectl proxy. So basically, the kubectl is the command for container. Now it is serving at 127.01. Okay. Okay, so basically, we created the cluster in wrong zone. So some services are available only in this zone only. So maybe we need to do it again. That's now default. Any questions till now?
I know computer is accelerated.
Okay, we are gonna go with the so this is a container spec. So this defines what kind of application I will be running on Kubernetes cluster. So basically, this is a replication controller. So basically, replication controller is a kind of subservice. So basically, how replication of containers should happen. Uh, so so I've given it named Redis Master. Um, the app that will be running on Redis. Uh, so the Redis master, so there will be master and slave, master and slave configuration. So once out of three containers that we created here, out of three containers that we created here, one of the container will be master, and other will be replicas of that master. And this is the specification, like different kind of a specification. So I only need there is only one replica here needed, and so this gcr.io, this is the Redis image. So image is nothing but a pre-configured template for a container. So as we saw in our previous exploration of Google Compute Engine, uh, uh, we saw that this container registry. So a container registry is something where your container images reside. Okay, so basically this gcr.io is a Google container registry where all containers will reside in Google Compute, in Google Cloud. Then this is just different configuration that is
Hi Ronak, I am not able